today. My part's going to be extremely short, but I want to walk through 2 or 3 minutes here just on what's going with the Ultrasound Guidelines Council. We did host UGC certification in Canyon last year. We had 41 technicians, and if you didn't get to see, actually there's one of our participants that was there. Mark Goes participated. We have a really nice facility. We lined the cattle up in 13 chutes in a row. If you've never seen that in a big arena, it's pretty cool to watch. This year we're going to set at 15 of those chutes, so we can actually handle a minimum 15 technicians each when we go through. In last year's event, we had 23 of those that actually passed certification. The reference technicians was David Aborn from, where's David from? Noah? Montana. Yeah, Montana. And then we had Mr. Wall, who's in Iowa, would be in the reference technicians. This year, I'm not sure how we're going to do that. The biggest update that UGC had this year, and some of you will look at this and may have watched what's going on there, but we're phasing out some old technology. That would be the Aloka that Noah hates really badly. It's my favorite unit, but Noah hates it because it's so big and bulky. The new systems we've got out there now are relatively small. I think they're 17 pounds compared to 100 pounds it seems like we've been carrying out. But because of this, we've got some algorithms that they seem to think are not getting marbling as accurately as they should be. So they have implemented a new test for those, and one of those labs, I think it's only 1 out of the 3 labs, has been brought into question, and they're actually going through a process to reevaluate their algorithms, and they're either going to have to come up with new algorithms or that system will not be certified anymore. So you'll be hearing more about that later on. They've got, basically they're on the clock right now. They have 90 days to get that remedied. These are the new stats that they put up there. And me personally, I don't like the move that UGC's gone in this arena here. They've made it easier, in my opinion, for these systems to actually pass as opposed to tightening those up. When you look at the bias of 1.6 on IMF, what would be driving that? We're scanning a whole lot of high marbling cattle anymore, whether that's thanks to the Angus cattle that are so high marbling. We've got the influx of Akaushi and Wagyu cattle, but the systems are having a tough time reaching high enough to get these high marbling cattle is what's driven part of this change here. But that's the new test statistics. If you look at that, that's what they're going to be tested on. But I do know that one lab is actually going through this process right now to update the algorithm. That same lab I knew is also working on the new Evo to work on algorithms for the Evo moving forward. There's some other technologies that they're working on that I've talked to 2 different labs that got some cool technology out of Japan they're working with that are very portable with some pretty neat systems I've got going on. This year, Dr. Lawrence, thanks to his help, he gets all the credit for picking the cattle out last year. We had a bucking bull, we had show steers, we had, looked like a Holstein cross of some sort. She was way tall, I promise you. He had some bulls in it, some heifers in it. It was an excellent set of cattle. So if you're an ultrasound technician and you want to go through the system and have a good chance of passing, he really does a good job of getting differences in those cattle and give you opportunities to pass the certification process. We're actually going to do, and made a change yesterday based on Dr. Lawrence and I had a discussion. If you saw what we did last year, we ran those cattle through in the morning. We'd haul them back to the feedlot, let them rest, feed, haul them back the next morning. This year, we're actually going to run the same set of cattle twice in one day. So we'll have a morning session, we'll have afternoon session. The cattle stay in our facility, never get onto a truck again until they go to the packing plant to be harvested. The cattle work remarkably well in that facility. It's cool under there even in hot times of September like we have. But we're going to try to get everybody on the 15th and 16th. So if you've got technicians that think they want to go through certification this year, shoot, we're not going to, the 14th is full, it's closed. So the 15th and 16th, we really want everybody on the 15th is what we'd like to do. We're expecting 30 technicians, but Patrick Wall was not sure that we might not have 60. There's a lot of international technicians going to be coming in this year. With that, I'm going to move forward with Noah Jesko. We get this question every year at certification. Should we collect data on the right side of the carcass or on the left side? Should the carcass data be collected on the same side that all the technicians ultrasounded on? So because of Noah, David Abel and myself, we actually collected this data with the help of Dr. Lawrence because he collected the carcass data on both right and left hand side. Noah, working on his PhD under me. Also just got accepted to vet school at Texas Tech University. So he's trying to finish up a PhD and go to vet school at the same time. And this just happens to be one of his projects. I threw him on here at the end. So, no, Jessica.
Thank you, sir. Did you set this to record, Rudy?
Yeah, it is.
All right. Thank you, sir. I'm Noah Jesco, like you said, PhD student at West Texas A&M. This study that we did at the certification, comparison of left and right carcass endpoints in beef cattle using Carcass Ultrasound. On the project were myself, Dr. Perkins, Dr. Lawrence in the back, and then Dr. Tennant, who is also at West Texas A&M. So like you said, our first objective was to compare the left and right side of individual animals using both Carcass Ultrasound and actual carcass data. And then our second was to compare the ALOCA 500 with the Evo Ultrasound unit. A little bit of literature. I just pulled some of these papers to show how far back ultrasound has been used and been used accurately to predict carcass traits. So fat thickness began in the late 50s, early 60s. Ribeye area also began in the 60s. And then IMF in the late 80s, early 90s. And then on this one, so some variation, thank you, sir, of carcass composition, yield left and right has been studied, and they thought that the association in differences was with techniques used at the plant, and we'll talk a little bit more about that at the end. So some materials and methods. The picture on the right is the setup that Dr. Perkins was talking about, where we actually had the 13 chutes, Aeroquip chutes bolted together in a straight line and ran the cattle through there, and it worked really, really well. And so what we did is we scanned 50 bovine during the UGC live animal exam at West Texas A&M. The cattle, we had steers, heifers, bulls, cows, and then talking about the different breeds, we had the bucking bull that he talked about, we had the dairy cows, I think we had a mini of some sort, I can't remember exactly, but we had everything that you can imagine, which is really good for the Carcass Ultrasound exam because it helps the technicians. I would like to point out real quick that all the credit on that went to Dr. Lawrence for picking those cattle out, but I'm pretty sure it was his grad students that picked those cattle out, so I'd like to give them a little bit of a shout out. So on day 0, a UGC certified technician, Dr. Perkins, scanned the cattle at the WT Research feedlot. And then on day 1, technician 1 scanned the animals on the right side with an ALOCA 500. And at the same time, technician 2 scanned the left side using an Evo. On day 2, technician 1 moved to the left side and scanned on the left side with the ALOCA. And then it wasn't until day 3 of the exam that technician 2 scanned the right side with his Evo. So Carcass Ultrasound measurements taken with both units, they included everything you would have at a normal exam. We had ribeye area, 12th rib subcutaneous fat, intramuscular fat, and rump fat thickness. And then after the final day, they were slaughtered at Tyson in Amarillo, and actual carcass data was collected by Dr. Lawrence's team at the BCRC, and they got ribeye area, fat thickness, marbling score, marbling number, everything that they normally collect. One thing that we did different is we did collect loins from the right side of the animal and brought those back to West Texas A&M, and then they were later analyzed for ether extractable fat. All the data that we collected was analyzed using SAS. So just some descriptive statistics. I'd like to point out right off the bat that all of these are in centimeters and centimeters squared. I apologize for that. Dr. Perkins told me I should have done that in square inches about an hour ago, and I didn't. I should have known already, but for publication, you know, they want these units, and so if you want to convert those, you can take the square centimeters and divide that by 6.452. So these are just the mean and standard deviation for the carcass attributes. Table 2, this is the statistics for the Evo Ultrasound. Okay, and one thing I'd like to point out here is that the Evo every measurement was larger from the Evo on the left side of the animal, which is in the exact opposite from the Aloca 500, where every measurement was larger on the right side of the animal. So first we'll look at some correlations. These are the correlations between each ultrasound unit and the actual carcass for fat thickness. The first thing, you can see the line right under the Evo left and the carcass right. That was the highest correlation at 0.87. And just disregard that. I don't know why that would happen, where when you scan on the left side it was the highest correlation with the right side of the carcass, but that's what happened. But if you don't look at that, the next two highest correlations are both for the Evo. So the Evo right side for fat thickness and the Evo left side for fat thickness were both more highly correlated than the Aloca. This is just another way. All of these will have a table and then we'll have a graph to look at, just because I think it's a little easier sometimes instead of looking at a table. Okay, so here in the red bars are the Evo and the black bars are the Aloca, and the two on the left are for the left side and the two on the right are for the right side. And once again, these just show you that the right side had higher correlations, and both for the right and left, the Evo was higher than the Aloca. The next one we'll look at is correlations for ribeye area, and once again the highest correlation occurred on the right side for the Evo unit, but this time the left side, the highest correlation was with the Aloca. I would also like to point out that 0.918 correlation was the highest correlation we had in any, and it was the Evo on the right side. So whoever that technician was, that's pretty solid. Yeah, that was me. Yep. So just looking at the same data, just once again, red and black, they haven't changed, just a different way to look at it. Whereas previously both red bars were higher, this one it's just the Evo higher on the right and the Aloca higher on the left. And then the last correlations we'll look at are for intramuscular fat, and then once again, now you see that the Evo was higher for the right side and the left side, once again, when compared to the Aloca for correlations on intramuscular fat. And also, you also see an outlier where you scan on the left side of the animal and the highest correlation is for the right side. Just looking at that exact same data set, there, red bars higher than the black bars. So now looking at some results, so comparing the carcass data to the Aloca 500. So Dr. Perkins told me not to present this data this way because it's kind of busy, but I told him that I would just tell y'all this is kind of busy and we'll kind of walk through it. Okay, so the superscripts denote differences within. So either within the carcass left-right or within the ultrasound left-right. And the subscripts represent differences between carcass and ultrasound, but for the same side. Okay, so whenever you're looking at the carcass ribeye area, 87.22 compared to 84.94, the superscripts show that there was a difference within the carcass. So the left side was significantly larger than the right side on average, of these carcasses. And then whenever you look at the ultrasound, there was also a difference within the ultrasound, left versus right, which you would think would happen if there's a difference in the carcass, that the ultrasound would pick that up and also have a difference. However, whenever you're comparing carcass right and ultrasound right for the Aloca 500, there was a difference where the ultrasound was significantly larger when viewing that image than what they actually found in the plant. Looking next at intramuscular fat, there's no superscript on the 4.89 because we didn't collect ether extract for that. So it is different, but I didn't want to present that because I just did, I guess, but I didn't want to present that because it wasn't the same side. But there was a significant difference between the carcass and the ultrasound on intramuscular fat for the Aloca. And then the next one we look at a difference in back fat thickness on the left side. But of note here, you'll see on the next one that there was there's not a lot of differences within ultrasound for the Aloca. But here there is. And this is your Evo. So now you can see that there is a lot of variation and a lot of differences within ultrasound, left versus right, when you're looking at the Evo, whereas there wasn't as much whenever you're looking at the Aloka. Here you still see the Carcass data hasn't changed. The differences between now, though, on the ribeye area, the difference is no longer on the right side, Carcass versus ultrasound, it's on the left side, Carcass versus ultrasound. But then whenever you look at back fat and rump fat, both of those are different within the unit. This is just the exact same data, looking at it. Okay, and then this one, this is what we really wanted to show, is the comparison of the Aloka directly to the Evo. And now there's no subscripts, there's just superscripts, and those superscripts are just differences between unit for the same side. So there's a difference in ribeye area between both units on both left and right, where the Evo was larger on the left but then lower on the right, both different between the two units. And then whenever you look at intramuscular fat, the right side there was no difference, but the left side there was. And once again, you see that that Evo is larger than the Aloka on the left, but smaller on the right. And then the exact same thing happens whenever you look at back fat thickness, but there was no difference in rump fat. So this is just looking at that, the exact same data, just looking at it in these bars. And you can once again see that the Evo left is bigger than the Aloka, but the Evo right is smaller than the Aloka, which is a trend. I don't really know the answer for why that would be, but it happened in every single measurement that we took. So some discussion, Ultra Insights published in their June of 2020 newsletter, some of these correlations, Evo to Carcass and then Aloka to Carcass. And then in number 2, you have a study that we did in the fall of 20, and those are correlations, the exact same thing, comparing Evo to Aloka, and then the correlations that we have from today. So you can see, or from September. You can see that the correlations between the Ultra Insights and the WT 2020 are all pretty similar. But then the ribeye area makes a huge jump whenever you come into the WT 2021, where that correlation on number 2 of the Evo to Carcass. But it stays pretty much the same on everything else. And this is just going to show you that this can be repeated. It has been 3 different times where you can go in and scan with an Evo and an Aloka, and you can get pretty much the same correlations on different sets of cattle. And then what we've kind of pointed out already is that the Aloka 500 versus the Evo, the differences were split directly down the middle. The Evo was larger on one side and the Aloka was larger on the other side, but there was no swapping of sides. And then there was a higher variation within the Evo unit whenever we were looking at left versus right, whereas the Aloka was pretty similar throughout. And then looking at the Carcass, differences within the ribeye but no differences anywhere else indicate that the animals are the same, but something is probably happening in the plant. And the idea is that whenever they are making cuts in the plant, that they're not the same person making every single cut. They might be 6'1" or 5'8", and they're making different cuts into that 12th and 13th rib, and that the angle or anything else could make those come out different whenever they go in to get graded in the plant. And then as far as the scanning left versus right, we found no reason why it would matter whether you scanned left or right. As long as the technician is certified and the unit has been approved, there really makes no difference if you're going to scan on the left or right side of the animal. So that's all the discussion I have.